Okay, so now let's talk about revolving an area around the y-axis. So let me remind you, this is what we've done before. So if I take this area, I draw a rectangle parallel to the y-axis. This makes this shell, right? Okay, that's what we've done before, where x was the radius, so the distance from here to here was the radius, f of x was the height of the rectangle, and then thickness. Okay, so now we're changing it. We're doing a different vertical axis. So now r of x will be the radius, f of x will still stand for the height. So let's deal with this one here, root x, y equal 1 and x equals 0. So there's my region, and I want to revolve it about x equal 2. Okay, so I know y equal root x and y equal 1, they would intersect at 1. So then I'm going to make my x equal 2, my center line, over here. Okay, so remember I draw the rectangles parallel to the axis of rotation. So parallel, there's my, oops, lost it on the edge there. Okay, so there is my shell. All right, so let's talk about where the radius will be. So the radius of the shell is from here to here, right? That's the radius of the shell, where this is the rectangle, and the distance from here to here is an x value, right? So here we go. So 2 pi radius height dx. So in order to get this distance radius, I want to say start here from the y-axis, go all the way out to 2, and take away x. All the way out to 2 and take away x. Then for the height of the rectangle, I want this height here. So I want to say go up to here and take away this. Go all the way up to here and take away this. So up to here, that gives me y equal 1. I want to subtract off this function, which would be root x. And then where am I going to build these rectangles from and to? I'm going to start at x equals 0 and end at x equal 1. All right, so here's a different one. Y equal x to the 2/3. Y equals 0 and x equal 1. Okay, so it's this area here, and again I'm revolving it around x equal 2, whoops, x equal 2, so that's the center, right? Remember, center is very key. Okay, so parallel to the axis of rotation, this is what my shell looks like, right? Okay. So my radius of my shell is from here to here. That's my radius of my shell. The distance from here to here is an x, right? So if I'm going to do volume by shells, radius, height, dx integration. So the radius will be, start here, go all the way out to 2 and take away x. Go all the way out to 2 and take away x. The height of the rectangle for my shell is just up to the function, x to the 2/3. All right, 1 over x, looks like this. Y equal x, and y equal 2. So same region we did before, so there it is. So now I'm going to be revolving it around x equal 3 over here. Whoops. So if this would be 1, right? So this would be 2, because this is y equal 2. I have to have context because I need to know where x equal 3 will be. X equal 3 is over here, right? So this is center at x equal 3. All right, so let's get my rectangle going. Oh dear, I don't want to do this problem, do I? Yeah, well, okay, well, let's just look at how hard this is going to be. So if I draw the rectangle parallel to the axis of rotation, right? If I draw it here, so see how I have a top function and a bottom function? That's all fine and dandy. What happens over here? These rectangles here have a different bottom function. So it doesn't say to use shells, does it? So I am not going to use shells, because that's going to be much harder to do, because I'd have to break it up into 2 integrals. All right, so I'm going to do it again. I'm going to say, it doesn't say to, so this is where I want you to be able to use your judgment and say, no, it doesn't say which method I need to use, so I'm going to use the other method. So this was 1 and this was 2, right? And then the center was here. Whoops, tried to get a different color. There we go. Center is x equal 3, and this is the center. So if I draw the rectangles perpendicular to the axis of rotation, these all have the same top function, then they all have the same bottom function. This is a much better way. But if the rectangles are perpendicular, what shape am I making? I'm making a washer. All right, so let's do it. So I know volume by washers is pi, outside radius squared. Get rid of some of this. Minus inside radius squared, and I know it's dy integration, so I want to be careful about that. So outside radius. So outside radius is all the way from here to here, right? This distance here. Okay, so I start measuring here, so I want to say go all the way to 3, the center, and take away this distance. So 3 subtract, and this function here is 1 over x, so I can solve that for x equal and get 1 over y. That's the outside radius. Okay, so let's see, let's use blue here to get the inside radius. I want this distance here, right? So I want to say, okay, go all the way out to 3, and take away the line, and that will give me the inside radius. So go all the way out to 3 and take away the line, y equal x, or x equal y. And then I want to make sure I put in y limits of integration. So y limits of integration, this where they intersect would be 1, right? So it starts at y equal 1, and then it goes up to here when that was y equal 2. So be careful that you're thinking about, and this is what I'm going to do on a test too, I'm going to be making sure that you use the better way, right? The shorter way. I'm never going to ask you to find the volume where you have to split it up into 2.